Hello Sam fans, and welcome back to this physics edition of Sam Science, where we're going to be looking at half-life. So what we'll cover very quickly is exactly what we mean by the activity of a radioactive substance. We'll have a look at the meaning of half-life, and we'll have a look at how to work out the half-life within a given graph. So first of all, we must ask ourselves, what is half-life and what do we mean by the activity of a radioactive substance? So it all goes back to the unstable nuclei and the isotope. So half-life is essentially the time it takes for an unstable nuclei in a radioactive isotope to decay. So an isotope, if you remember from chemistry, so C1, so an isotope is an atom that has different number of neutrons, but protons and electrons are pretty much the same. Okay, so that's what I mean by an isotope. An unstable nuclei is when you have a nuclei that has unbalanced forces. So the particles within the atom itself, so your protons, your neutrons and your electrons, in a normal atom, the forces are balanced, so therefore the nuclei is stable. But then in some circumstances, especially in radioactivity, the nuclei becomes unstable. So what that means is the forces that actually are inside the atom themselves are unstable, so they are unbalanced. So it could be that one particle, such as a proton, for example, it could be that the force of a proton is weaker compared to the other sections of the atom, so neutron, for example. So all you need to know, an unstable nuclei, is the structures within the atom itself have unbalanced forces. Okay, and so we can add that to our spider diagram. So unstable nuclei. Okay, so half-life. So as I mentioned earlier, half-life is the time it takes for an unstable nuclei in a radioactive substance or an isotope to decay. So essentially to run out of, if you like, of its radioactivity. Okay, so the longer it takes, the more weaker, if you like, the substance becomes, and the danger of that radioactive substance becomes less. It lessens over time. Okay, so the activity of a radioactive substance is the number of nuclear decays per second, and that's measured in BQ. So we can add that here as well. Just move that so you can see. So activity of a radioactive substance is the number of nuclear decays. Okay, so number of nuclear decay per second. Okay, and that's measured in, we call it BQs, or we can use BQ for short. Okay, so now what we're going to have a look at is we are going to have a look at how to work out the actual half-life and the activity of radioactive substance, and we're going to use a graph to do that. So here we go. Okay, so here is our typical graph. You could get this in an exam, and it asks you to work out the half-life of a particular radioactive substance. So as you can see here, I've got my axes here. I've got time at the bottom. Time, the unit is minutes, and activity, so how dangerous, if you like, it is, how radioactive it is on the side, and that's measured in BQs. Now lots of students get the BQs and the time mixed up. They think BQ is the time that it's measuring. It's actually not. It's the amount of activity. Okay, so how radioactive the substance is. Okay, so as you can see here, it starts off as quite high BQ, and as you can see over time, and this is measured in minutes, okay, it then decreases. So you've got this slope coming down. Now, in an exam, they will give you an example like this. They may put it on like lines, like a graph, where you can draw it on where you're going to measure the activity. They may not. So do be prepared for either or. Okay, so how do we work out the activity? So half-life essentially is half the amount of activity. So if we look here, it goes up to 1200. You can see here it's 1100 is his activity, and you can essentially halve it each time, but it all depends on what the question is asking you. Okay, so if we go to, if I said to you, if I asked you a question, what's the time of the radioactive substance, or how long it takes for it to decay if it has a activity BQ of 800, how would you work that out? So you get your ruler. In this case, I don't have a ruler, I have a bookmark, but you will have a ruler in the exam. Find 800, go across, then you go down as accurately as possible. Okay, and it's just shy of 5, so I would probably say that's probably about 4.8, I would say, or even 9. Okay, and then if they ask you in the exam what's half of that, so what's half the activity of 800, we know that half of 800 is 400, so again you get your ruler. I'll do this in blue this time. Find 400, go across, okay, and then you go down. So here, as you can see, it's directly at 10. Okay, so then if it asks you, right, what's the activity of the radioactive substance, let's say half of 400, for example, so again you're going to halve it again, so you know that half of 400 is 200, and if it asks you for the time, and it could say to you, right, how long does it take for the radioactive substance to decay at 200 BQ, find 200, it's always going to be half, always, okay, hence why it's called half-life. So go across, go down, and then you can see it's 25, 26 perhaps, okay, yeah, about 26 minutes, okay, at 200, and then finally if it says to you anything less, it will keep going depending on what the question is asking. Okay, so as you can see there, we started off at 800, and then half of 800 we know is 400, half of 400 we know is 200, and it could even ask you for 100 as well, and then we know that half of 200 we know is 100. So again, you find your 100, go across, go down, and it's probably about 32 minutes. Okay, so as you can see here, this is 100, 200, 4, and then 8. Okay, if the activity was up here at 12, then you know that you'd have to halve 1200, okay, which then you can then work your way down, but as you can see it hasn't, it's actually started at 1100 here. It all depends what the examiner's asking you. Okay, so each time the activity will always half, okay, it won't quarter it, it won't anything, it's always going to be half of what the activity is each time. And this is a typical exam question that they may ask you in the exam, figuring out the time or the activity of half-life radioactive substance. Thank you very much, SAM fans, for listening, and please do check out my other videos on GCSE Physics equations and of course the acceleration equation as well.